All right, friends, there's a lot of untangling threads today. Day two of my journey. So, yesterday I was wondering about if I needed to think about limits at all. How much did I need to do about limits? And I realized I think about one specific limit a lot in my life. So, if we have any number and divided by zero, one divided by zero, a million divided by zero, pi divided by zero, that is undefined. But as we approach zero, all of those approach infinity, right? So if we have a very tiny number, 1 times 10 to the negative 1 million, which is the same thing as 10 to the negative 1 million. I wasn't sure where I was going when I started that. 10 to the negative 1 million power, that fraction approaches infinity. But dividing by zero is undefined. So I think about that a lot, about why dividing by zero is undefined. And like part of that is because you can't divide anything into zero groups, right? We have 20 people and say divide that into zero groups. You can't. At the very least, it's going to be one group of 20 people. But if we cut us all into tiny pieces, that was a terrible example. Ah, right. So I think about that limit a lot. And that helped me think about, the limits in calculus that we have to think about. One of the things that I was noticing also during my observations, during my exploration, is that they keep calling it the tangent line problem, as like there's an issue with the tangent line. And I couldn't exactly figure out what they meant. And what I did finally figure out is that a tangent to a curve at one point only has one point, and one point does not make a line, right? Which is why we think about those secant lines approaching that tangent line, and having infinitesimally small differences, just like that 10 to the negative millionth power. And so what would we get when it is infinitesimally small? So that's why the limit becomes important in these derivatives. Also, difference quotient from yesterday is the definition of a derivative. I don't know why they had it listed as like two separate things. Truly, in this textbook that I was referencing, on one page, it is called the difference quotient. And on the next page, it is called definition of a derivative. And it is the exact same equation. So that was something confusing. And it also gives me insight to why I was so angry about it when I originally learned calculus. So it is tedious. It is tedious to do the whole H thing where the H's cancel out. It's a lot of steps. And then, 3 days later, when you learn the power rule, and it's so much easier, you go, why did I do that whole long thing when I could have just done this easier thing? And part of that is not fully understanding what's going on, right? Because I don't think I did. I said that yesterday. I did not understand the concept of the secant line and H being the difference between X and that getting smaller and smaller and smaller. Like I did not understand what the big equation was doing. So at the time I just thought, why'd you make me go through all of that when I could have just done the little one, the easy one? Because I didn't have a deep understanding of derivatives yet and did not actually understand what was going on with that difference quotient / definition of a derivative equation. I did some Khan Academy videos, so I hadn't done any videos yesterday because I couldn't find the difference quotient on there. I was like, why is that equation not on there? And it's because it's under the definition of a derivative. So I totally understood his thing about concept of derivative. I probably could have watched that yesterday or, after my first video. I watched that and I was like, I understand all of this. I understand what is going on for the concept. Something interesting that I liked. So when we are talking about lines, when we're talking about slope of a line, we say delta y over delta x, change in y over change in x. That's our slope, right? But when one of the things, the notations for a derivative, which I do remember, dy over dx, right? And so is this is a thing that where that difference, it's telling us that difference is infinitesimally small. That is showing us that we are like doing the derivative thing and the tangent line thing. So that was kind of an interesting notation moment for me to notice, and for Sal Khan to point out, I forgot about intervals and that's a thing, right? So that was one of the things in the video where I go, oh yeah, intervals are a thing. That is something coming up. And then I also realized that my secant drawing from yesterday was somewhat unhelpful because of the fact that I went through to two different sides of the curve. It was in two separate parts of the curve. So I'm going to redraw that into a more helpful visual representation, right? So instead of going through two different parts of the curve on two different sides of the axis of symmetry, this is a better secant drawing going through a curve where, as we get to the tangent, it gets closer and closer to that line that's at that point, because the one that I had drawn yesterday would have actually like flipped around the curve. It wasn't a very smart job, but this is because I am learning more and noticing more. And I think those were all of my notes about today. So the difference quotient is the definition of a derivative. What do you know? I was angry about that at the time. The tangent line problem is that you can't make a point with one point. You can make a point with one point. You can't make a line with just one point. But and then I remembered why limits were important. So this was a lot of, not a lot of new information, but a lot of disentangling things from yesterday. So this was very good, very important.